Welcome to BC Gnomonics. In this video, we're going to be taking a look at the Planispheric Astrolabe, a device so complex and with such a wide array of features, it has been dubbed the mathematical jewel of astronomy. By the end of this video, I hope you'll understand why, as its capabilities far exceed anything possible with a sundial or nocturnal. At the base of this instrument, we have the function of modeling the celestial sphere, much like an armillary sphere, although this astrolabe uses stereographic projection to project the celestial sphere onto a two-dimensional plane. And because of this two-dimensional projection, the celestial sphere is made latitude specific, and a separate plate or a tympan is required for each latitude of use, this one being for 42.5 degrees, and the one currently installed being for 44.5 degrees. Other plates are also included with planispheric astrolabes, this one specifically being able to be used with this terrestrial plate or this universal horizon plate, depending on the function required. Now, the main strength of the astrolabe comes from its ability to manipulate three key variables: the altitude of a celestial object, the time, and the date. With any two of these known, the third can be determined, thus yielding an incredibly vast array of computational abilities. Some key features of the astrolabe include telling the time during the day using the sun, at night using the stars, predicting the times of sunrises and sunsets, and predicting the point in the celestial coordinate grid of any given star or the sun at any point in time. So, as you can tell, the astrolabe is incredibly versatile and can be used to solve any number of problems relating to the sun or stars and the time, date, or altitude. With use of the lines radiating out from the center zenith point, the astrolabe can also be used as a solar compass, as on the reverse, the alidade can be positioned along the outer degree scale and pointed toward the azimuth of the sun that is observed by taking a sighting and determining the time. With any of these variables, with the other side of the variable known, the equation can easily be reversed, allowing the time to be found or allowing the position in the sky to be found, depending on your needs. On the back of the astrolabe, we also have a shadow square here, which allows for the height or distance from the observer of an object to be measured. Now, because the astrolabe has such a wide and vast array of functions, far exceeding those of any sundial, I have filmed a number of videos on this subject, each focusing on a practical hands-on demonstration of a function of the astrolabe. Now, if you're interested, I suggest you watch those videos on bcgnomonics.com, as each one will focus on a separate function of the astrolabe, such as finding the time using the sun or stars, or the use of the universal horizon plate, just to name a few. Hopefully this has given you an adequate overview of the astrolabe itself, though, and I thank you for watching, and hope you can appreciate the full breadth of features of this very complex astronomical computer.